Hi students, today I am going to explain anomalous properties or abnormal properties of molecules. This topic comes under chemical bonding chapter. So here the first molecule I am going to take here, first molecule is hydrogen fluoride molecule. You know I have both already hydrogen fluoride. Here whose molar mass is 19, and this hydrogen fluoride having a high molar mass when compared to water. So whose water molar mass is 18. So when compared to water, this hydrogen fluoride is more molar mass, whose molar mass is 19. But having a low boiling point of 19.4 degree Celsius. It having a low boiling point when compared to water. It having a low boiling point, that is 19.4 degree Celsius. So next one is the electronegativity difference of hydrogen fluoride is 1.8. Electronegativity based on polar molecules. Polarity we can give electronegativity different values. So whose hydrogen fluoride electronegativity value is 1.8, but it is covalent nature. It is covalent in nature and less soluble in water. Less soluble in water. Next point is it acts as weak acid. Hydrogen fluoride acts as a weak acid and exhibits equilibrium conditions. When we are doing reactions, it exhibits equilibrium conditions. So it acts as a weak acid. Next point, it gives no precipitate with aqueous AgNO3. Aqueous AgNO3 means silver nitrate solution. When we add hydrogen fluoride to silver, aqueous silver nitrate does not give precipitate. But other hydrogen halogen compounds gives precipitate with silver nitrate. Other means, for example, here in the place of X, I am going to take chloride, bromide, iodide. These hydrogen chloride, hydrogen bromide, hydrogen iodide gives precipitate with aqueous silver nitrate solution, but hydrogen fluoride does not give precipitate with AgNO3 silver nitrate solution. And next point is hydrogen fluoride reacts with glass. Hydrogen fluorides reacts with glass, but other halogens, hydrohalogen compounds does not. There is no reaction gives with glass. No reaction occur in between other halogen compounds and glass. But in the case of hydrogen fluoride reacts with glass, it gives some reaction. Right, this is about hydrogen fluoride molecule. Next one is water molecule. Here the molar mass of water is 18. Next point, the water has a lower molar mass than hydrogen fluoride but high boiling point of 100 degree Celsius. It having a high boiling point when compared to hydrogen fluoride. Here hydrogen fluoride boiling point is 19.4 degree Celsius, but in the case of water molecule, the boiling point, it having a high boiling point, that is 100 degree Celsius. It has a high density than ice. When compared to ice and water having a high density. So only because of less density, ice floats on water. Next point, it shows high density at 4 degree Celsius. We know that water having a high density, but at the 4 degree Celsius, it's showing a high density. Water showing a high density. Next point, it has a high latent heat of vaporization and fusion. It has a high latent heat of vaporization and fusion. Next point, it has a low viscosity and decreases with rise of temperature, right? When compared to other liquids like castor oil or any oil content or any organic liquids, this water having a low viscosity. When we rise the temperature, the water content will evaporate. It decreases, right? So it can flow easily on floor. Next, it has a high dielectric constant of 79.5. So it having a high boiling point at 100 degrees Celsius. It having a showing a high density at 4 degrees Celsius, and it having a high dielectric constant of 79.5. This is about water molecule. And next one is for ammonia molecule. So ammonia molecule whose molar mass is 17 It has high molar mass but low boiling point of minus 33.3 degree Celsius. So ammonia whose boiling point is minus 33.3 degree Celsius, below the freezing point of water. It is highly volatile. Highly volatile means it can evaporate easily in atmospheric air. Volatile means evaporate easily. When we keep in atmosphere, this ammonia liquid evaporates easily. So this ammonia molecule is highly volatile and hygroscopic in nature. Next one, it does not react with alkali metals. Look here, next point, some of the non-metals like I2, sulfur and phosphorus soluble in ammonia. So some non-metals like I2, sulfur and phosphorus soluble in ammonia but insoluble in water. These are the anomalous properties of ammonia molecule or abnormal properties of ammonia molecule. Next molecule is nitrophenols. These are covalent but soluble in water. Nitrophenols are covalent but soluble in water. So many covalent molecules does not soluble in water, but in the case of nitrophenols, these are covalent only but soluble in water. They form both inter and intramolecular hydrogen bonding. We know that already, inter and intra. So in the case of nitrophenols, these nitrophenols involving in both inter and intramolecular hydrogen bonding. These are the only two properties present in nitrophenols. Next one is alcohols. Here in the case of alcohols, here I am going to take ethyl alcohol whose molar mass is 46. It has a high molar mass than water, right? It having a high molar mass than water, but low boiling point, that is 71 degrees Celsius. When compared to water, it having a low boiling point, that is 71 degrees Celsius. It is covalent but more soluble in water. This is also covalent only alcohol but more soluble in water. It has a high molar mass but less density of 0.78 gram per cc. But it having a less density when compared to water. It having a less density, high molar mass but less density. So next point, it has a high molar mass than water but more volatile. This is also